It is given two complex numbers in the Cartesian form, and we need to rewrite them in the modulus argument form. And to do that, we can consider given numbers on the ordered diagram. X-axis is the real part, and the y-axis is the imaginary part, and we can split it into root 6 over 2 minus root 2 over 2i, and we can see that x coordinate is the real part, it's a positive value, so it's somewhere here, and y value, it's the imaginary part, it's negative, so this complex number is somewhere here, so that this coordinate is root 6 over 2, and this coordinate is negative root 2 over 2, and it's z1. And to convert it into modulus argument form, we need modulus. Modulus is just a distance from the origin, and it's just the Pythagoras theorem, or it is given a formula that modulus of a complex number, or it may be denoted as mod of z1, is square root of x squared plus y squared, where it's x, it's y. So it just becomes root 6 over 2 squared plus root 2 over 2 squared, and it becomes what, square root of 6 over 4 plus 2 over 4, and it's what, 8 over 4 and root, and you can see it just root 2, so this distance is root 2, and we need argument. Argument, it's the angle, and notice that the starting point is here, and in anti-clockwise it's positive angle, in clockwise it's negative angle. So this argument of z1 can be given as such angle, and it will be positive, or such angle and it will be negative. And notice that theta must be, it's actually what its argument, it must be from negative pi over 2 pi over 2. But you remember, for any argument you can add or subtract any number of full revolutions, 360 or 2 pi. So as usual, we consider a small triangle, right angle triangle, to find this angle. It may be a supplementary angle, and then from this diagram you give the final value of theta. But how to find this angle? It's it can be considered just a tangent of this, let it be alpha, firstly, because it's some supplementary angle, and it will be acute angle. It's not the final answer. So from a graph we can say that tangent alpha, it's what, opposite it's just length, and when you consider such supplementary right angle triangle, all lengths will be positive, and you find tangent of the acute angle. So tangent is what, root 2 over 2 divided by opposite over adjacent, root 6 over 2 cancel, and we get root 2 over root 6, or 1 over root 3. For AI you may use just a calculator. For AA it is suggested, because it may be questioned without a calculator, you should know that it's you should know 30, 45, 60, because it's what the tangent is sine over cosine to be root 3. Root 3, it's what, it's 30 degrees, or pi over 6 in radians. And then using the supplementary angle, we give the answer for what? For the argument of the z1. So argument of z1, it's actually this theta. It becomes what? It's 2 pi minus pi over 6, or just negative pi over 6, because it's directly this alpha but in clockwise direction, and in clockwise angles are negative. Hence z1 in modulus argument form, it becomes what? Root 2 cosine negative pi over 6 plus I sine negative pi over 6. It's also the same as root 2 cis negative pi over 6, or root 2 e to the power negative I pi over 6. It's the Euler's form. And we do the same for z2. For z2, 1 negative 1, and you may notice that it's what is just isosceles triangle. 1 1 imaginary, real, and it's quite easy. It's clear that it's what, 45 degrees, or in radians it's pi over 4, and again it's 0 for argument, and it may be given as 360 minus 45 or 2 pi minus pi over 4 in radians, or just pi over 4 but in clockwise direction, so it's negative pi over 4 or negative 45 if it is in degrees. And modulus, it's quite clear. If 1 1, so hypotenuse it's root 2 or square root of 1 squared plus 1 squared if you use root of x squared plus y squared. So z2 becomes root 2 cosine of negative pi over 4 plus I sine of negative pi over 4, or it's the same as root 2 cis of negative pi over 4, and it's the same as root 2 e to the power of negative I pi over 4. And shows that z1 over z2 is equal to this expression. For division, it's useful to use Euler's form. If it is given in this form or this form, you may rewrite in Euler's form and then give the answer in this form or this if it is required, because for division it will be absolutely the same properties as for usual powers. So we need what? z1 over z2, and z1 becomes it's what, root 2e negative I pi over 6, and divided by root 2 e to the power of negative I pi over 4, and it looks like 2 to the power of 10 divided by 2 to the power of 3. It's what, 2 to the power of 10 minus 3, and it's absolutely the same, but instead of 2 there is e. It's 2.7 and something. It's just a number. And these are just numbers, so we can simplify them, or it's usual division for usual numbers, and you can see that root 2 cancels, and we get just e to the power of minus I pi over 6 minus negative I pi over 4, and it becomes e to the power negative I pi over 6 plus I pi over 4, and common denominator is what? 12. So let's write it. So it becomes what? Negative 2 pi I plus 3 pi I, and you can see that it becomes e to the power of what? Pi I over 12. And if we rewrite it again in form r cos plus I sine, notice that modulus is 1, so it becomes 1 times 1 is not required, so it's cos pi over 12 plus I sine pi over 12 as required. But on the other hand, we can divide z1 over z2 in the Cartesian form. So z1 and z2 to be in given Cartesian form. So it becomes z1 over z2 is root 6 minus I root 2 over 2 and divided by 1 plus 1 minus I. And we need finally to be a plus bi. What does it mean? It means we should get rid of this I in the denominator. How to do that? We multiply by the same but with opposite sign to get a formula a minus b, a plus b, and it just becomes a squared minus b squared and I squared negative 1, so minus negative 1, it's plus 1, so it's 2. 2 times 2, it's 4, so denominator is 4. And we need just expand the numerator and it becomes root 6 minus I root 2 plus root 6i, and this multiplied by this, I times I negative 1 minus, so plus root 2. And we split it into two parts, real and imaginary, so it becomes root 6 plus root 2 over 4 and plus I root 6 minus root 2 over 4. And since it's the same as z1 over z2 but in this form, let's rewrite it below. It's absolutely the same as cosine pi over 12 plus I sine pi over 12, and it's clear if it's the same. Real parts must be the same, and with I also must be the same. So we can conclude that cosine of pi over 12 is, we should keep the exact form because the exact form is required here. It becomes cosine pi over 12 becomes what, root 6 plus root 2 over 4, and sine pi over 12 is root 6 minus root 2 over 4. And that's all for this question.